Okay guys, a little different thing today. I got something in the mail yesterday and I'm just now getting a chance to try it out. First of all, it's a power board that's designed to be used with these breadboards. These are pre-engineered things that you can connect circuits using these cables. If I can find an extra one. You have these wires, they have pins on either end, and you can plug one in here and then you can plug it over here, and that's a way of putting circuits together without building a PC board that you can test. Now in this case, this is a power supply designed to fit here. It has these pins that go into these holes where this is positive, over here is positive, the blue is positive, the red is, the red's positive, the blue is negative, and there's a stripe here and here. And then this is where you put your circuitry, and this is where you can get your power. And you have two sets of these, and there's this little jumper, we call it. And if it's on this side of the jump, these two pins together gives you 5 volts. This one over on this side gives you 3 volts, and in the middle it's turned off, so there's no power. And then down here you can do other jumpers to ground for 5 volts. I'm not sure what that's there for, but anyway, this is what I knew to use. I guess you could pull power off of here in addition if you needed it. The other thing, it has 2 sources of power coming in. You have a USB and then this round plug it in thing, and it says 7 to 12 volts. Now it's understood this has got to be DC. So what I have is a DC charging circuit plugged in, and it's 12 volts. So I can plug this in, it fits perfectly. Plug that in, and if I turn, this is the on-off button, turn this on, it says I now have power going out, and depending on where this piece is, right now I put it over here on 3 volts. So I'm going to insert this. I put those 2 there and those 2 there, and it fits into the first sort of layer, quadrant thing. And then I've wired in one of my new boards that I've been having trouble with. I'm using power over there, and I'm thinking maybe I'm using the wrong power, maybe I'm using too much. So I've got this set to 3.3 volts coming in, and I've got the orange wire going over here, and this is plugged in like this, so it's actually going in inverted. And this is the VCC, this is the voltage input. So this will be 3 volts here. The next one is ground, so that's going to be the ground. Orange is the hot, which is 3 volts. The black is the ground to ground, and then I'm going to turn it on. And when I turn it on, I'll let you see, I'm hoping you can see that green light. Now what I'm going to do is wave my hand in front of the sensor, and you see the second green light come on. So this sensor is working just fine with 3 volts. I'm thinking I may have been overdriving this with more than 3 volts. I may have been giving it 6, maybe, I don't know. I haven't tried it with 5 yet. I'm just happy to see it work with 3. And I happen to have a volt regulator, a tiny little voltage regulator that I can adjust, and I can take in 5 or 6 and I can adjust it down to 3. So if I put a volt regulator in front of this device and then take my 2 probes of the signal out, which is DO, which is this signal here, that signal goes out like that, and then I share the same ground as I do here. You see there's a break here, so this is the last point you can have the same ground. So they're now grounded. Then this would be my leads going into my soundboard, and then I can put my hand in here and I should be able to hear the chuff sound and see the fan run. And that board is over there, and it runs on a battery, which is interesting because it really wants to run on 5 volts. So I'm so smart. I have 2 of these, and I have 2 more of these boards coming, I think, or at least 1 more. So I got more boards coming so that I can power my other devices equally and get them a nice, safe, clean voltage, 5 volts or 3.3. So I am hoping I now have a means to operate with this trigger and continue with my development. I've only got 15 minutes today. I got here late. I had to get my car worked on, oil change time, and so I'm guessing I won't have time. At any rate, I've got a few other things that came in the mail today. It's hard to show you, but I have an amplifier, a charger circuit that works with these batteries that I'm using. So I now have well, it's on here. It's not going to be clear, I don't think. I'm going to shut this off. It's not going to be very clear here, but the idea was we were concerned about the power and buck boost and all that. So I had a battery charger that I put in this circuit, and the battery then was providing the 12 volts into 12 volts, 5 volts into my microprocessor. And this charger then is charged by the outside circuit, and we could have filters for that. Anyway, I'm happy. It looks like I'm going to have these infrareds working as long as I put something in front of them. I have this tiny little volt regulator. It's about that big, and it has a little thing on it you can turn. It has inputs and outputs. So if I can run like 5 or 6 going in, I can set it to 3.3 coming out, and then give that to the sensor, the infrared sensor. I should be okay, and my little lights should work perfect as the chuff trigger over here. Boom. And that'll help us go. All right, I'm gonna go 15 minutes now, 10. I talked too much. Okay, just wanted to see this new thing. It's pretty cool. It's not expensive. It's not. It's like $6. I got this, and I got a whole pile of wires. I don't know, they're around here somewhere, but I got a big pile of wires that came with it, and it's really neat. All right, I'll talk to you later. Okay, I'm in the handheld for a real quick. I went ahead and brought my system over. This is the Puff and Chuff system, and I have this battery that's been charging, so it's charged. So it's going to run off of that battery, no outside circuit. So I can just turn it on. You hear the steam being released, and it's now ready to do what it's supposed to. And I have a steam whistle button. I have a bell button, and it's, if you keep holding it, you hear the bell, and you let go, it stops. And I have a chuff button, which, as you can see here, moves the fan. Well, it did till I moved it. It was moving. Oh, crumb. Well, it was working. I don't know what happened. All right. Any rate, now what I can do, I can bypass this button here that I'm pushing. I can bypass this by coming over here and going to this pulse to ground, and that should send a little bit of energy to that button. So I make sure this is plugged in. I turn it on. You heard the chuff. It's the initial. It's on the 3 volt signal. You look down there and you can just see one green light. There's a second green light as my hand goes in front of it, and it chuffs. Honest to God, it was making the sound, and it was making the fan move. I swear. There it goes. There it goes. I must have a loose wire. See it work? My hand, it makes the sound, and the fan moves, and it's not even connected. It's just the signal coming in. This has its own power supply. So my idea for the little PC board, the little regulator, given it's a dedicated 3 volts, would work. The 3 volts is working to trigger the chuff. And we have the sound, and it's all running off of its own battery. Whew! We got it. We got it. I can take any power on the train in the tender, and I can run it through my volt regulator to 3.3, run that power here, then that power runs this. Oh, man. Okay, okay. We're cool. We're cool. And the fan works. Look. Now, next thing I want to understand is how much energy is coming into this fan. I can sit here and run this test, but I don't know, what's coming in. So I'm going to use a voltmeter and try to catch how much voltage is coming into this, because I can change the duration, but I have yet to figure out how I can change the volts. And I'm not sure. I wrote Andy, he hasn't written back. He's busy, I guess. But when he gets a chance, he'll tell me, what does this transistor do for the voltage coming out? What's coming out? We're using a D5, and we've set it as an output, but I'm not sure if it's 5 volts, 3.3. I think it's 3.3. If it's 3.3 volts, that's all I'm getting. I can simulate that on this other side over here with 3.3, use that as the trigger, so that I see with 3.3 how much duration will I need to operate this, and I can put it into a smoke system, run the system, and sit there and do the chuffing and watch the smoke and dial in the heater and the duration of the fan if I know it's getting 3.3 and it's consistent. So that's the game plan, is to understand what's the system doing for me. In the old, see, this is sort of new to us, new to me anyway, having a microcomputer running this thing, because we used to just run voltage. We could adjust it and just interrupt it and send it to the fan. And it could be 5 volts, and I could crank it up. Man, that fan would go 6 volts. It would just scream. But it's probably too much. Anyway, now that we got this new heater, I got to dial everything in on that 8 ohms. Okay, so that's the quiz. We have a chuff. Now you don't even hear the chuff. Now it's stuck in the on mode. I don't know. Oh, it's because it's turned off. That's turned on. I don't know what that was. And now I'm not getting the chuff. I don't know what, I boogered something up here. All right, I'm going to stop while I'm ahead. I'll bet you my battery's low. That battery hasn't been charged in quite some time. Oh, man. Okay, fun and games. Later.